What's going on? My name is Zach Holcomb with Additive America. Welcome back to Tool of the Week. This is episode 2. I'm joined by Richard Savage of Savage Automation today. He's going to show us a new tool. That's why it's Tool of the Week. And I'm not even going to call it an EOAT to start. It's just an end-of-arm tool. So, Richard, what do you have for us this week?
Perfect. This is a great end-of-arm tool. I love this one because this is one that the customer did not purchase. We did the design on it, looked fantastic, and they bought something else. And I don't know if they're happy with it or not, but I want to show off what we could have done, what they could have had. Maybe they'll feel a little remorse in not going with it.
I like that. I like
so
it.
So this is for a 4-cavity here. And we've got these little parts, kind of like a barb part. Now I've modified this part so that it does not show off any of their IP in it, but it's still the same concept. We'll go through a little bit about what we're doing on this end of arm. So this is again one of these end of arms where we call it the hybrid. We really do a lot of these for when you get big, because 3D printing's limitation is size. Zach, what's our size on the HP printer?
Give or take a little bit, 15 inches by 12 by 12, somewhere in that range.
Yeah, we've pushed that a couple of times. I think you guys like twisted it and laid it completely diagonal in the bed.
Yeah, we're all about that 3D hypotenuse, type thing.
Right.
Little side to side, angle to angle, corner to corner.
Exactly. But we pushed that limit far enough on enough of these that we really like to do this kind of aluminum backbone and then these quadrants on it. It also makes it a little bit more modular. So if we ever have to replace those pieces or do some damage control after a crash, this makes it a little bit easier. So on this guy, we've got the 3D printed sections here have an ID gripper. What this guy does is when it's pressurized, there's a little cylinder in here that squishes this rubber bead. That rubber bead expands out and friction holds that part on. So this goes forward into this barb, expands out that bead, friction holds it on there, and then we've got our little gripper jaws here for the runner, or the sprue that lets the plastic get out to these parts.
Okay.
So choosing a gripper is super important on end-of-arm tooling. We spend a lot of time kind of modeling this up and trying to decide what kind of gripper, how we're going to hold on to this part. Suction cups are a nice, simple method, easy. Grippers are a little bit more of a difficult, complex technique to use. But this is really going to determine, are you going to get the part every time? Is it going to be repeatable, or are you going to struggle with it? So we like these ID grippers a lot for something that's got a hole in the middle, because they don't rely on the outside geometry. They just kind of go in, puff up, and pull the part off.
That's very cool. Are those parts there, like, is that portion that you're describing a printed part, or is that an off-the-shelf part that you're finding somewhere else?
That's an off-the-shelf part. So that's actually manufactured by a couple different companies doing them. The ones we buy come out of Italy. They're kind of an off-the-shelf. They thread in there. It's kind of tough to print that one. Anything that's got to hold pressure like that, it's tough to print. Yeah. We could try it, though. You want to try it?
I think we should, actually. I think I have actually seen one of those, like, extremely beautified case studies that has come from HP. Shows like they had a part where they had like a little internal channel, had like a little coil system, and then it had a gripper. And when they activated it, it either squeezed in or squeezed out, but either way.
Oh yeah, I know the one you're talking about. It looks like a big old trumpet with these coils in it.
Yeah, almost like a tuning fork. Yeah.
See, this one I actually drew up a couple where you'd have an internal channel and you'd have to print it. It might work out of the PA12, but I think it'd work better in like the TPE, and you'd print an internal chamber. So instead of trying to squish a bead, a rubber bead like that, you'd just be like filling up a balloon. So you apply pressure and you'd get that sidewall to balloon out. Mm-hmm. Yeah, we ought to try it sometime. These ones are, I like off-the-shelf stuff really, because we can easily replace those. They're going to fit every time and be the same. And I can keep a stock of them without feeling like it's a real custom part,
Mm-hmm. Totally. Totally. You've got some portions of that there that are kind of a little different too. I mean, it definitely doesn't look like, I'm looking at the blue part there. That's the printed part. It doesn't really look like something that you could machine or make in any other way. Would you say that that'd be pretty accurate?
No, that'd be super tough to machine. And, some of this is just for support. That's why it's there. You probably wouldn't machine it if it was aluminum. But one of the things I really like on this is we showed our printed channels in here. And this one, we've got a reject and an accept channel. So when you're running parts as an injection molder, you often have things that happen during the run, especially in tight tolerance medical parts. You'll have a part that drifts out of tolerance. Now, there's a lot of reasons for that. Maybe your water's not right on your molding machine, but it occurs that you have parts that go out of tolerance. And you don't want to stop the press, pull the mold, repair it, do all these things because you got a production order to get out. Mm-hmm. And so what we'll often do is say, hey, cavity 1, we're going to separate that out. We're either going to quarantine those ones until we get customer buy off on the defect, or we're just going to throw them away while we keep running. So in this one here, we've got these 2 separate circuits. You just hook up your air line coming out of the center here to either one of these circuits, and you can reject or accept on the fly without having to completely repipe your hoses on this end of arm, which is what you kind of see on traditional end of arms. So on this reject line, it's manifolded all the way down. We'll run a little loop line from this top one to the bottom so that you just have to have one supply line. And then that handles our runner and then any parts that we choose to reject. And then the accept line does the same thing. It runs all the way through. And normally, if all your parts are good, all 4 of those are on that one airline.
Gotcha. Very cool. All about keeping cycle times down, trying to keep that machine in sequence or, keep everything running. So, like you said, sometimes you are setting up an injection mold tool and you've got a situation where you don't quite have the machine right up into its perfect sequence, but you don't want to stop the machine every single time. It may take a few bad shots, to get things going, get that mold warmed up on the inside and get everything flowing the way you need to. And the last thing you need is your end of arm, kind of interfering with that a little bit. Is that
exactly?
Okay.
Exactly.
Not bad for a 3D guy. You know what I mean? I don't even run these.
I mean, you're catching on. You're getting there. We'll update some of your poor terminology, get rid of that EOAT stuff. But
that was the best, man. I'm sorry. I love it. That lead in. I was editing that video up and I was doing it without headphones on in the office every single time. Man, I come back and hit the start. And Grant and Alex, they were cracking up laughing, man. They just they thought it was hilarious.
Oh, that's awesome.
Appreciate you being a good sport and educating me.
You try to educate you and keep you on the right track. You 3D guys.
I know some of us think that injection molding is dead. I'm not one of those guys. It's all about how we accentuate each other's markets and we can all work together. You know what I mean? Injection molding will always, always, always be a tool in the toolbox. Get it? You like that joke? Tool in the toolbox? I'm a dad. I'm allowed. That's right. Well, cool, man. You got anything to add on that one for Tool of the Week episode 2?
Really, I think we covered most of this. The really cool thing about all of this is they're all so different, and yet we can make them on the fly. We can have our off-the-shelf parts, and yet we can adjust and customize all these 3D printed components to really fit every need.
Yep. And always, when it crashes and smashes, we've always got that digital file ready to go to produce it exactly the way that first one was because we loved it. It worked great. Or can you just make that minor modification because if I could change anything, I would just change that. So you're able to have that kind of that flow with your customer, your client, to where you're able to very easily reproduce something exactly the way they did the first time without having to go back through, set up machines and set up operations and stuff like that. Very simple, overnight, press start, run the printer again. It's not that easy, but it's way easier than setting up all the tools again in a CNC machine. So
that's what the good thing is, it's that easy for us. We just call you up and say, hey, print more of those. And I don't have to worry about if you screw 10 of them up. That's not my problem.
Right. That's what we're trying to get right. We just want to screw up 8 of them, man. If we could just get it down to 8, we'd be perfect.
There you go. Now, you mentioned another good thing that really applies to this is that you can go back to exactly how it was. And if it worked great, it worked great. But if you need to make tweaks, you make tweaks. often we see a customer from several years back, they'll have a 4-cavity mold like this. They'll be running this and the product will take off. They'll be like, hey, we're building an 8-cavity mold. Well, we're already set. We adjust our little base bracket, copy over our 3D printed parts, and we've got another end of arm tool already set.
Nice. Yep. Yeah.
We don't have to remachine and redesign and redo everything because we only designed for a 4-cavity.
Yeah. Yeah, I like that. The modularity of it is key. And again, it's keeping it simple, stupid, baby. The old KISS method. You can apply that same methodology and use the latest technology all at the same time. You're totally right. Totally right.
Right.
Well, cool, man. I really appreciate you jumping on and doing an episode 2. That's a really great tool right there that you just showed us. For everyone at home, we really appreciate you checking in on these. Please give us the likes and the subscribes and all the things that all the cool kids say on the YouTubes. But mostly if you're here, if you're watching on LinkedIn as well, we really appreciate it. Give us a little share, it all really helps. And it really, we appreciate all the love as well, obviously. So that's it. You all good on that one? Episode 2 is a wrap. That's Richard Savage. Yeah, we'll get another one next week. That's Richard Savage with Savage Automation. I'm Zach Holcomb with Additive America. You can hit him up, savageam.com. Did I get it right this time?
Mm-hmm. That's correct.
And additiveamerica.com. We'll catch up with you next week. Appreciate it.